Okay, hello everyone. My name is Tim Dudgeon from Informatics Matters. This is a OpenRiskNet webinar, one in a series of webinars that is listed here. We're coming to the end of the season. There might be a few more added on at the end. We're not sure about that at the moment. But today we're talking about deploying applications to an OpenRiskNet virtual environment. So what is an OpenRiskNet virtual environment? Well, if you attended earlier webinars, you'll have heard about this, but just in case you haven't, I'll try to give you a very brief overview. So a virtual environment is an environment you can create on your computing infrastructure, whether it be physical infrastructure, physical servers, sometimes known as bare metal, or you can also deploy it onto cloud infrastructure, such as Amazon Web Services or Google Cloud. And the virtual environment that you deploy allows you to build and deploy applications into that virtual environment and then make those applications available to your users. And OpenRiskNet has created a number of applications that have been deployed into a virtual environment. Obviously, the OpenRiskNet project itself has a focus on chemical safety assessment. And so most of the applications are related to that topic in some way or another. And the key thing to a virtual environment is you can create your own one. You're not dependent on ours, and you can deploy whatever you want to it, our applications as well as your own applications. And this webinar is about how to deploy your applications. So if you have an application that you're thinking might be useful to deploy to this sort of environment, this webinar will show you how you might go about doing that. So what forms this virtual environment? Well, it's based on Red Hat's OpenShift product, which is basically Red Hat's distribution of something called Kubernetes. So what is Kubernetes? Kubernetes is a container orchestration platform that is backed by Google, but also has a large number of contributions by other companies as well. But container orchestration, what does that mean? What are containers? So containers are a way to package software and deploy it into an isolated and controlled manner. And it's been made popular in the last 5 years or so by Docker. Many of you might have heard of things like Docker containers and Docker images and things like that. So Docker have made this popular, but Docker is not the only way to run containers, but it is the predominantly used one. So now we understand a bit about containers, we can come back to Kubernetes. Kubernetes is a container orchestration platform. And what that means is that Kubernetes can manage a cluster of computers and manage the deployment of containers to that cluster of computers. Kubernetes manages all of that for you. It's a bit like a distributed operating system. So whereas Windows or Linux is the operating system of a single computer. So I was saying that whereas Windows or Linux might be the operating system for a single computer, Kubernetes could be considered as a distributed operating system for your cluster of computers, and it manages the running of containers. So now finally back to the top, what is OpenShift? Well, OpenShift is a distribution of Kubernetes. It's 100% Kubernetes, but Red Hat adds in various other things that add to the Kubernetes environment, things that are likely you would have to add yourself otherwise. And included in that are enhanced is support, the potential for paying for support if that's what you want. They provide much hardened security, and they provide continuous integration and continuous development capabilities. So not only can you run your applications, but you can build them in the first place. And so here we have a typical OpenRiskNet virtual environment sitting on top of some form of hardware, whether it be physical hardware or cloud-based hardware. And that OpenRiskNet virtual environment is providing things like storage, like the continuous integration, continuous delivery capabilities. It's providing application infrastructure that your applications might want to use, things like databases or message queues. It's providing a lot of features that allow you to monitor the environment, and it provides sort of security capabilities such as single sign-on and certificate generation and things like that. And if you want to know about deploying a virtual environment, then we have an earlier webinar that walks you through all that process. So take a look at that. Today's webinar is about how you deploy applications into this virtual environment. And the two typical scenarios we might want to consider. The first one here, application one, where you already have a set of container images that are located on some external repository, such as Docker Hub. And you can deploy those images into the OpenRiskNet VRE, get them running, and start using them. The second scenario, application two here, is similar in a way, but actually we're starting from the situation where we have source code located in some sort of source code control system, such as GitHub or Bitbucket or something like that. And in this scenario, the OpenShift CI/CD capabilities pull down that source code, build the application binaries or whatever is needed, packages them into the containers, so it builds the containers in the first place, pushes them into a registry that is located within the virtual environment, and then goes through the deploy process in a manner that's similar to what would have happened for application one. We're largely going to be concentrating on the application one scenario here because it's a bit simpler and a bit easier to describe, but some of the applications that we've deployed also go down the application two route, and that's useful because it uses the full capabilities of the OpenRiskNet environment. So a brief introduction to containers, a little bit more on this. So what is a container? A container is a set of Linux processes running in an isolated environment that's managed by features of the Linux kernel. And in some ways, they can be thought of a bit like a virtual machine, but they're much more lightweight and much more efficient. That's because they're handled directly by the Linux operating system, by features such as C groups and namespaces. And unlike a virtual machine, which has a complete layer to emulate the hardware and then a complete operating system layer, the containers just run on the Linux kernel just like they would normally. It's just that they're isolated by those features so that one container can't interact with another container or with the host operating system unless you specifically allow that. And what's also very important for you regarding containers is that you can package them up into things called images. So those components, that software that would be running as a process within Linux can be packaged up into a container image, and that image can be distributed to your colleagues either directly or through a central registry such as Docker Hub. So just to give you a very brief overview of how this sort of isolation works, here's a quick video that shows you initially. We run on my host system. This was my laptop. I'd do a ps-ef to list all the processes that are running, and you see a large number of processes that are running. Now I do a Docker pull to pull a CentOS image. That pulls very quickly because it was actually already pulled. Then I run that CentOS image, and I am now inside the image, and I again do a ps-ef, the same command, and this time I only see two processes. One is the PS process that I just executed, and the other is the bash process that I use to get into the container in the first place. We don't see all the processes going on in the host system. And so our container is isolated from the host system and is isolated from many other containers running in the environment. So how do you create these container images? Well, Docker provides a number of tools available for doing this. There are other approaches. You don't have to use Docker tools, but they are the most widely used ones. And most typically, you would write a Docker file, which looks like this on the top right corner. It's like a set of commands that from means use this as a base image. So the base image is something that already has Python in. Workdir says move into that directory, add components from the outside into the container, expose a port, and then run a command. This would install something based on the requirements file, switch to the user nobody, and then the command that would run is Python and then app.py. So this is an application that my colleague Alan Christie created. It's a very simple Python application that runs a web server and basically says hello when you connect to it. And all you need to define that container and build an image from it is this Docker file. And it will go something like this, as in the bottom box. You could get those artifacts by cloning the GitHub repository, move into the repository, and then run some commands. Docker build is the command that uses this Docker file and would create a container image from those commands. And then we do a Docker push. That pushes that built image into a repository under my namespace, and it calls it PySimple. So that image is now available to me and to others to use on other computers. And to use that, you would use a Docker pull command, pull the image, and then Docker run, which just basically fires up the image, runs it as a container, and then to just test it works, you can either open the URL with a web browser or just curl to get to it. Relatively simple. People who are familiar with Docker and containers will be very familiar with this. If not, there's tons of documentation on the internet describing all this. Just Google for Docker and containers, and you'll find tons of stuff. So let's move on. We'll come back to that container in a little while, where we show how to actually run it, not in Docker, but in the OpenRiskNet Virtual Environment. But conceptually, how does that container run within an OpenRiskNet Virtual Environment? Well, containers don't run just as containers, they actually run as what are termed pods. So pod is something that basically manages the runtime of a container. But to all intents and purposes, they are really quite similar. A pod is a wrapper for a container or a number of containers, and it's the pod that actually Kubernetes manages, not the container directly. But you don't typically create pods directly. What you do is you create a deployment config that defines the deployment of pods. It's the configuration of a deployment, and it's like a pod definition. It defines things like which ports you want to open, which volumes you want mounting into the pod, security concerns and things like that. And for instance, you can specify how many replicas of the pod you want to run. So if you said, right, I want to have 3 replicas, Kubernetes will do its damnedest to make sure there are 3 copies of those pods running somewhere on your cluster. As long as resources are available, Kubernetes will ensure that 3 copies of that pod runs. But those pods could run anywhere on your cluster. You don't actually know which host they're running on up front. And if one pod gets into trouble and hangs or crashes, then Kubernetes will restart it, quite possibly on a different server. Similarly, if one of those server crashes, Kubernetes will then reschedule that pod to run on another on another server. So what this means is the location of those pods is not fixed and is not known and can change over time. And so if you had an application that was wanting to access that, this would get quite tricky because you'd be forever having to find out where the pods are running. So to solve that, Kubernetes has a concept called a service. And the service can be thought of as a front end to a pod or a series of pods. And it allows access from within the Kubernetes cluster to those pods. So you don't access the pod directly, you access the service, and the service knows where the pods are running and will load balance across the pods, and the service won't change. The service will always be there. Even if the pods get rescheduled and move around, you can still access those pods through the service. So the service allows you to access your container running in a pod. Think of it, that container could be running a database or a web server or something like that. You access it through a service. So you can have another pod running in another application that wants to access that database or that web service. It does it through the service. But the service only provides access internal to the cluster. If you want to access it from outside, you need to create something called a route or an ingress that basically acts as a bridge between the outside world and the service. So with a route in place, you can, let's say, access your web application through a browser. The browser accesses the route accesses the service, and the service accesses the pod and handles the request. So those are the absolutely fundamental concepts of a Kubernetes cluster. There are plenty more of Kubernetes object types, at least 20 or so, and custom ones you can be created as well. But these are the fundamental ones that really need to be understood to begin to understand how to deploy applications. So the procedure for deploying your application would be, step one is to create whatever container images you need, quite possibly only a single container image. And then once you've done that, step two is to deploy to OpenShift. And there are multiple approaches possible for that, and we'll go over some of those. So creating your container image, step one. You can either create those container images externally and push to a registry such as Docker Hub. That's exactly what we showed earlier for the PySimple example. Or you can use OpenShift's continuous integration and continuous delivery mechanisms to actually build the container images within the OpenShift cluster and push to OpenShift's own container registry running within the virtual environment. Our examples are primarily going to be the first of these, but the second one is also an option should that be of interest to you. And then step two, deploying to OpenShift itself. Again, multiple approaches are possible. There is a web console, which we will see in action in a minute, and there's also a command line interface that, and both of those provide pretty well the complete range of functionality you need to be able to manage an OpenShift Kubernetes cluster, including deploying applications, as we will see. Both of those, the web console and the CI and the CLI, use the REST API that Kubernetes and OpenShift provides, and you can also use that directly should you want, but typically you'd access it through the web console or the command line interface. And with that web console or the command line interface, you can either do these deployments manually and interactively on the command line, just typing in commands, in the web browser, in the web console, just pointing and clicking, and we'll see that in action in a sec. It's relatively simple to do, but it doesn't lead to a very reproducible or automatable process. For that, it's better to use things called templates that, again, we're going to look at, and the new kid on the block, operators, which are a bit like templates on steroids that can handle the full life cycle of your application, not just installing it, but uninstalling it, but managing it and upgrading it and backing it up and things like that. Operators are relatively new. Over time, they will become much more prevalent, and it's worth taking a look at them if you are interested in deploying applications to a Kubernetes environment. So we're now going to show some examples, and these are the examples we're going to show. Firstly, we're going to show how to deploy an application directly through the web console. Then we're going to show how to deploy exactly the same application through the command line interface. And for that example, we're going to use the PySimple one that we saw earlier. Now that's a bit of an oversimplistic application. Real-world applications are a bit more complex than that. So we're going to move on to showing how one of the OpenRiskNet partner applications, Lazar, is deployed, and that's using templates and the command line. We'll see that in action, and then we'll look at an alternative approach of doing that, using those templates to deploy directly from the web console. And then we'll finish up by looking somewhat superficially at deploying a much more complex application that is composed of out of multiple containers, multiple components that all need to interact with each other, and how you can sort of automate the deployment of those sorts of applications. So let's jump out to the web console, where we are here logged into the OpenRiskNet development site. And it's a fairly standard web application. You connect to it, you log in with your username and password. We've already done that, and we're logged in as in this case as an administrator. That's not to say you need to be an administrator to do everything, but it's just easier to demo this. So I want to now deploy this simple web application that we saw earlier into our OpenRiskNet development environment. So the first thing we'd do is to create a new project. A project, also known as a namespace, is basically a project isolated from each other. So you can give people different access rights in one project from another, and you can control what happens, what one project can access from another project. So I'm just trying to type as I speak, which I'm not very good at. So we're creating a new project, webinar PySimple, and that's now been created. And so I jump into that project, and it's now basically an empty project. I've got nothing in there of any note. But what I want to do is to deploy an image that is the PySimple image that I showed you how to build earlier. So we click on build in, on deploy image. I want to deploy it from an image name, which is external. I type in docker.io/tdudgeon/PySimple. Now that tdudgeon/PySimple is the name of the image that we saw earlier, how we could build and deploy and deploy it into Docker Hub. And the docker.io just means this image is located in Docker Hub. So if I then pull in the details of that, OpenShift has pulled the information on the container image, and it is now ready to actually deploy this for me. I can specify some environment variables. I can specify a few other things if I want to. I don't have to. I don't need to in this case. So I just say OK. And now if I continue to the project, I'll now see things being created in the project. I'll see this here is the deployment config that I mentioned earlier. The deployment manages the firing up of, in this case, a single pod that is running our Python application, which is running the Python web server. And also created automatically for us is a service that provides access to the pod, and also what's not created automatically because OpenShift doesn't really know whether we want one or not, because is a root. So OpenShift doesn't know whether we need to access this from outside of the cluster, so it doesn't create one by default. So we'll just go in and create one. Again, lots of parameters you can specify, but we don't need to. We can just use the defaults. And now we've got a root to this application. I can connect to it, and here is our PySimple application saying hello world, and saying what the host name is, and a few very, very simple things like that. Now, here's our pod running through the web console, also through the command line. You can go in and look at things like the logs of that container. So this is the what's being logged by the application as it's being accessed. You'll see here a GET request to the root URL, which gave a 200 response. That was me in the web browser calling that, making that request. You can also open a terminal session into the pod. So now I'm running within the container itself. So I can say ls, I can say pwd, I can do whatever I want inside this container. So this is a good way how you can find out what's going on, how you can debug things and things like that. So that's basically our deployment of a very simple web application purely through the web console. The next thing I'm going to do now is to delete this project. I'm going to find it and delete it. So all that hard work is now being deleted. And if I can do this properly, simple, delete. And now OpenShift is now deleting this project. Now I am going to jump to a terminal window. And which one do I want? I think I want this one. No, I want PySimple, which is this bottom window. Now I'll try to make this a bit bigger for you so you can see it and expand the font size a bit so you can see it. Hope you can see this, maybe a little bit more. So there's a command line interface. If you're using pure Kubernetes, you'd be using the kube control command line application. In OpenShift, there's the equivalent application is called OC that wraps up all the kube control commands plus a few others. So OC, who am I? It tells me I'm as a developer. So first thing I want to do here is OC new. I just want to check I'm actually on the right server. OC status. Check I'm doing this to the project. No, that's not the. Okay. Okay, this is actually running on an local environment called Minishift, not actually the development site, but it really makes no difference. What you're going to see is exactly the same. So it's OC new project webinar PySimple. And now I hope you can still see this. I'll just try to close up the console a little. Now we can say OC new app docker.io/t Dudgeon/PySimple. And what you'll now see is OpenShift is doing exactly the same thing. It's taking that definition of the container image and making a reasonable guess about what you might want. And it says, right, I'm going to deploy a single pod. I'm going to open up whatever ports are defined in the Docker image, and I'm going to create a service to your application. And so if I now do a OC status, you'll now see that I'm in the project webinar PySimple. The deployment was deployed 29 seconds ago, and there was one pod running. And so I could now go in and access that from a web browser as well. So that's not a particularly exciting application. What I'll do is OC delete project. I can't type project/webinar PySimple. And so that project has now been deleted. So basically, there's two ways of deploying that really simple application, both from the web console and from the command line. But as we saw, that application is not particularly realistic. It's overly simplistic. So what we're now going to do is look at a more realistic application. And we're going, as an example, we're going to use the Lazar application, and that is a predictive modeling application that's created by one of the project partners. And we're going to look at how that application looks and how we can deploy it. And we're going to do that using a template. So basically on this link here, so this link here, if I can, you'll see the artifacts we're going to be using to do this deployment, and a big README telling you more about Lazar and about how to deploy it. In fact, if we just go up one level, you'll see in this OpenShift deployments directory, you'll see directories for a number of the applications that we have deployable to an OpenRiskNet Virtual Environment. Most of these look somewhat similar to this, giving you information on how to deploy the application. So basically, what we have here is a template, which is a YAML file, which if you just scroll through it, it looks pretty scary and pretty horrible. We're not going to look at this in detail here. There's a lot of stuff here. We're going to break it down into some more digestible parts in a sec. And we also got the README, and we got a script to deploy the template and to undeploy it. So if we jump back to the slides, this one, losing which window in. So back to presentation mode. So the template, as I said, is a big YAML file that describes and defines lots of things. Key things it defines are the objects that it wants to create. And as you might expect, there's a deployment config there, there's a service there, and there's a route there. There's also an image stream, which is basically as a reference to the container image that is going to be deployed. Strictly speaking, that's not necessary, but there are some advantages in actually including the image stream definition. But in addition to the objects that are to be created, a template provides a number of other very important things. There's metadata, which describes the template. There are labels that get applied to the objects that get created. So for instance, we apply a label app equals Lazar to everything that gets created, which makes it very easy to identify those objects and, for instance, delete them if you want at the end of the day. But most important are the parameters. Parameters are user configurable options that get applied to the template. So the template, the object definitions effectively contain variables that are filled by the parameters that you define. So we might, for instance, have a parameter for the Lazar service port that has a value of 8088. And in the service definition, you might use that variable. And the default might be 8088, but the user at deployment time could override that and change it to another value. So the parameters are key to configuring and parameterizing the deployment of the template. We'll look at the template in a little more detail. Here is a part of the parameter section. So here is one particular parameter named image tag, and it has a value of latest. And so you've got a parameter that has a name, it has an optional default value, it has a description, other things can be provided as well. But that parameter can be, you can either use the default value, or when you deploy, you can specify a different value that overrides that. And you'll see in the template a number of those parameters. Here's the section, or part of the section, for the deployment config. And you'll see the definition of the container using a parameter, and definition for things like readiness probes and liveness probes that allow Kubernetes to find out the state of the pod, resource requests and things like that. Here's a section for the service and the route. Here's the service on the left-hand side, the route on the right-hand side. The service here uses, there is our Lazar service port parameter being used. The route is the front end to the service. So the route is saying, I want to be a route for the service whose name is Lazar, blah, 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 etc., etc. Here are some annotations that are applied to the metadata that allow us to configure the template service broker, which again, hopefully we'll look at in a minute. Now, let's have a quick look at trying to deploy this application. So here we are again on, we've got those artifacts checked out. Lazar.yaml is the template. So to check who am I? Check I'm doing this in the right place. Developer OC status. Okay, so I need to log in here. Log in. OpenRiskNet.org 8443 -u admin. Okay, and I'm now, okay, now I'm in. Now if I do OC, who am I? I'll see I'm on as admin, and I'm on the OpenRiskNet dev site. So what I now want to do is I've got the commands written down in a crib sheet. So I will just jump to there and copy them. So I've done this, I've done that. I want to know, here's the Lazar one. What I need to do is create a new project. So I'm creating a project called Lazar. Then, because this container runs as a predefined user, I need to modify the security settings slightly to allow that to happen. No time to dwell on that at the moment. If we want to look at this deployment, if we cut the deploy script, you'll see what it does is it just sources an environment file where we can set up some environment variables, and then it basically processes the template. OC processes the template. OC create then actually uses the process template to create the artifacts. So in this case, I'm just going to deploy, and where am I? Oh, I haven't created a set env. That's my problem. That's my fault. I'm on a different computer compared with what I was expecting to be on here. So I'm not quite as prepared as I was hoping to be. What I'll do is I'll process this directly. And OC, let's have an OC process. Copy and paste is not going well here. The only thing I need to parameterize here, whoops, I haven't got used to this mouse. No, still can't get it. Ah! Oh. Roots underscore base name equals Lazar dot dev dot openrisknet .org. And OC process, that looks right to me. OC create myself there. Here we are. So with luck, nope, I haven't done this quite right. The root base name shouldn't have Lazar on. So I'll just delete this, delete install app equals Lazar. Do OC delete all. Okay, back to where we started. Now do this correctly. The base name doesn't contain the Lazar part. Okay, now that is being deployed. If I do OC get all, I will now see things that are being created in the application. And we'll see a pod. In fact, we're seeing 3 here. Don't worry about that. That's because I made that initial mistake. We've got the replication controller, which is created by the deployment config. We've got the service. We've got the image stream. We've got the route. We've got all the things that we expected to see. If we now jump across to the web browser, and we'll now go and look at this Lazar project. I've actually got to view all and then Lazar. Here is that project, that Lazar project being deployed. Here's the pod being created. It's in light blue at the moment because it's in the process of firing up. But you see, basically, we've got the deployment config with the pod. We've got the service that has been created. We've got the route that has been created. So as soon as that pod fires up and starts, we would then be able to access the Lazar application. So while that's happening, let's just jump back to the slides, and it takes a minute or 2 minutes most to deploy that. So I'll just point out now some other application templates that we've created. Some simple examples you might want to look at are BridgeDB and the JGU Weka application. All of these are found in this deployments directory. Some more complex examples. There's Jupyter Hub, which is a Jupyter notebook deployment scenario. We've got our own Squonk computational notebook that hopefully we'll touch on in a sec, and Jackpot from the National Technical University at Athens. So that's plenty of examples. What we'll do is move on and look at Squonk briefly as an example. Now, Squonk is a much more complicated application than Lazar. There are a number of different components. The databases, the message queues, the single sign-on. There are different components to the application, including a web front end and different service tiers and things like that. This diagram sort of explains this in a slightly simplified view. In terms of just what components are present. What we've done is we separated them out into 2 main types of component. One are what we call infrastructure components. So there's a Postgres database, a RabbitMQ message queue, and the Keycloak single sign-on system. These we've decided are generic. They can be used by any type of application in the OpenRiskNet Virtual Environment. So we put them into their own namespace or project called OpenRiskNet Infra, so that any application can use them should they want to. And then we've got the Squonk specific components that I won't go into in detail because we're going to run out of time. And these, essentially, each of these would be a deployment config, a pod, a service, and some of these are routes because they're externally accessible. Some of them aren't. And the arrows just show the interactions between the different components. So I hope you see is that you've got a reasonably complex application architecture here, much more complex than just a single container. So the approach we're taking here is to create some Ansible playbooks for doing the deployment. At the heart of this are still templates that define all these things, but the templates have been broken out into a number of relatively small, a number of templates, each of which does a relatively small part of the overall problem. So we've got infrastructure playbooks that basically deploy the infrastructure. So that would deploy or also undeploy the Postgres database, the RabbitMQ, the single sign-on system. Then once that's deployed, we can then run the Squonk playbooks that deploy the Squonk Squonk computational notebook itself. We have something called Chem Central, which is a chemical search database. And we've got playbooks there for deploying it, for undeploying it, and also loading data into it. So loading chemical databases into there. And various miscellaneous playbooks for creating users and running tests and things like that. So I think, yeah, that's an overview of how we run Squonk. Let's just quickly jump back to here we are. Yep, we've got Lazar. It's all deployed. I'll just go to the root, open the root, and hopefully, why did that open the pop-up window? Don't understand that. Let's try again. Nope, it's still. Let's go to Chrome, which handles this much more easily, much better. So, okay, here we are. Here is the Lazar service deployed. Wasn't much hard work from us. We just run a deploy script, but there was quite a lot of work who went into defining that deployment script. So finally, the Squonk deployment. We won't have time to see this in completion, I'm sure. Where is the window I need for the Squonk deployment? Just bear with me again.
So I think there was one here. So what do you want?
The Squonk OpenShift.
Code. You want to deploy the mini sheet?
Yes. Yep. Okay. Alan's with me here, and I'll leave him to actually do the typing because it's his laptop and he understands where everything is better than me. So basically what we're going to do, we've got we're using the same mini shift environment that we used earlier for the PySquonk. And we've got this number of playbooks. We're going to just show you initially how we just fire off the initial one, deploying the infrastructure, and then we'll finish. By the end, we might have seen it deploy. It takes about 5 minutes or so to go through this procedure, so it may not see the light of day before the end of the webinar, but it'll be useful at least to actually see how it runs. So here we're running the playbook to deploy the infrastructure. So that's the one that deploys the Postgres database, the RabbitMQ, the single sign-on system. And so we're now just running through the Ansible playbook that goes through all that process. As I said, it takes maybe 5 minutes to do that. And if we look at the console, we'll actually see wrong username. We will see a project called Squonk Infrastructure that is in the process of being deployed. At the moment, you're seeing the Postgres database being deployed. After that, you'll see some other components being deployed. So let's break there and finish off the slides and just have a brief opportunity for questions. So I think we're pretty well finished here. So there are a number of best practices to consider, and we've provided some guidelines here in this link that cover quite a large number of topics, but there is a lot more to it than I've been able to show in this 50 minutes or so. Security aspects of your containers is a critical thing to consider. Part of that is trying to create small containers that don't contain bloat, don't contain things you don't need. It's important to consider how much resource, and that's typically CPU usage and memory usage, that your containers need. And in our cases, what we prefer to do is everyone to use the single sign-on system, so we have a sort of single record for who's logging into the system and who's using it. So look at that document there. It's quite detailed in terms of sort of how you can optimize these things and how to sort of deploy your applications in a relatively secure manner. Finally, you can actually look at using these applications. If you're more interested from the user's point of view, just go to this, what we call the landing page, that lists all the applications that we've got deployed, which includes Lazar, it includes Squonk, and a large number of other applications. They're all listed there. So finally, just to conclude, I think it's clear that OpenShift and Kubernetes is a very powerful application platform. I'm very happy with the choice we made at the beginning of the project to use that. There are a wide number of applications for deploying, options for deploying applications. We've seen some of them today, but not all of them. And it supports very simple, but also very, very complex application topologies. Obviously, it's more complex to deploy the complex ones, but it is possible. The CI/CD capabilities allow you to build those applications as well as to deploy them. And particularly for the complex applications, there is a significant learning curve. There's no doubt about that. But hopefully, this webinar will have introduced you to that, and there's plenty of documentation available. And things like YouTube videos and the like on Kubernetes and OpenShift. And for us, it certainly provided an excellent approach for a robust deployment of applications and for automating that. So just sign off with some acknowledgements. So thanks to the EU for funding this project. Thanks to all the partners who've played an important role in the project, and also thanks to Red Hat for providing OpenShift and for supporting us in that, and also to the Swedish Science Cloud, where the development and the production sites are running. So that's it for now. We've just got a minute or two at the end. Let me quickly just see what's happening to the Squonk deploy. But yep, so it's still running. We're waiting now for the single sign-on, the key cloak, to be deployed. If we go back to the console here, we'll see the Postgres has been deployed. Now we're in the process of deploying the single sign-on, and after that, the RabbitMQ will be deployed as well. We don't have time to look at that or to look at the next stage, which is deploying the notebook itself. So at this stage, let me finish and let's see if there are any questions. No, so if there aren't any questions, let's finish here. The recording of this webinar will be available on the OpenRiskNet website in a few days' time, so you can take a look at it there, and feel free to pass it on to other people who might be interested. Also take a note that we do have at least one more webinar planned, but possibly other ones. And keep coming back to the OpenRiskNet website and finding out what's going on the project. So thanks to everyone for attending. Thank you. Goodbye, everyone.